happy Wednesday. So, just a quick check-in on Zybooks. Almost no one's in chapter 4 yet. That's okay. We still have time. But again, my reminder, if you get behind, it just gets worse, right? That's why I was up till 7 in the morning the other night trying to finish some stuff up, because I kept getting behind on it. So eventually you can get caught back up, but it makes for a really rough day or week or whatever. So don't leave this for finals week. And you don't want to be doing this over Thanksgiving either. Or maybe you need an excuse to get away from the family. So maybe you do want to leave Zybooks and be like, oh no, I got to get all this homework done on Thanksgiving. I can't come out to hang out with the weird uncle. Okay, keep that in your back pocket. I'll assign some extra homework if you need it. But no, so we got through most of chapter 4 here, which was nice, except the labs, right? You keep working on the labs here. So I want to spend a little bit of time talking about the rock, paper, scissors, lizard, Spock, because there's actually a bunch of different ways we could go about doing it. And that's sort of the fun, right? As long as it gets the job done, we're good. But there's lots of different ways to approach it, right? And that's really the art here, right? So make sure I get my check create a welcome script, not the create git repository. This one will give you all sorts of headache if you're trying to put it in a folder that already is a git repository. Putting git inside a git confuses git. That's all. So I'll show you what it looks like actually, just for fun here. So this was lab 2? I think it was rock, paper, scissors, lizard, Spock. So if I check this box and it makes it a git repository, and I'll do it in a new window here, and I come over to GitHub, let me finish, it's got to make its files. All right. Usually we see there's a bunch of stuff here, but now all we see is the name of the folder. And it says it's empty, and it says it's a file. So if you see this, go and show it in Explorer, open up that folder, lab 2. Inside of here there's a .git folder, that's the hidden folder. If you don't see those, you can go to your view options and go to view and say, yes, I want to show the hidden files and folders. We always want to see hidden files and folders. We hide these for normal people because they'll break stuff. You're not supposed to mess with hidden files. But developers, we know what we're doing, at least hopefully, so we can mess with the stuff we're not supposed to. So don't delete the one at the main folder. That'll be really sad. You want this one. But the one that's inside of the folder that's not showing, go delete that one. And now it says, oh, hey, I see a bunch of stuff again. Now that there's not a Git repository inside of a Git repository. Then it'll be okay. So you might run into that. So just don't check that box. The other ones are fine. All right. So the first thing we're going to do is pick a random number, right, for the computer to throw. Right, so we'll get. I thought 1 to 5 was pretty easy. You could do 0 to 4. Some people were thinking to use lists and use indexes and had some really cool thoughts, which is fun. That's a lot of work, though. Right, I'll be honest. So I want to do simple before we make anything more interesting. So we'll just pick a random. So we'll have the computer throw is going to be random randint 1 to 5. So it'll be a number 1, 2, 3, 4, or 5, right? Because we get both bounds, both of these inclusive here. With these. Then we need to ask the player. So we get the player throw is an input of, now we could just print out a menu and that makes life even easier. So I'll do that. So I'll say print 1 for rock, print 2 for paper. I'm just going to copy that. That feels easier. We'll go 5, 4, 3, right? Rock, paper, scissors, lizard, and Spock. Does lizard have 2 Z's? 1 Z. Okay, looked weird. And then if we're asking for a number then, I want this really to be an integer. So we want that an int of an input. And number menus are pretty easy. They don't always have to use them, but sometimes they're handy here. Right? So now there's 3 things that are going to happen. Right? We're either going to win, we're going to lose, or we're going to draw. Win, lose, or draw. Now, the first example I gave you, sort of on purpose to be, it's not misleading, but it's one approach. You could say, oh, hey, let's say if the player's throw is equal to 1, that's rock. Then, okay, if player's rock, now what's going to happen here? We could totally do this. We could say, okay, so now how do we win? If we're rock, we win if the computer is scissors or lizard, right? So then if inside of here, we can say if the computer throw is equal to 3 or the computer throw is equal to 4, print you win, right? So if they were 3, if they're 4, right, we win. Nice. Now, we've got these like numbers here, and they're a little awkward to read and look at. So there's actually a cool thing we can do. I think it talked about it in chapter 2. We just kind of skipped through it here. Up at the top here, I can make a variable just to put a name to something. It's one of the great reasons we have variables. So I could say rock equals 1, and paper equals 2, scissors equals 3. Now, usually we put them in all uppercase if we want to just set a value there and not ever change it. There's ways to do it in Python. For now, we're just going to do this by convention. So then we'll have lizard is 4 and Spock is 5. Now, what that lets me do is I have a name for all these things. So I can say, hey, if player 1 is rock and computer throw is scissors, right? Doesn't that look a little bit nicer? And lizard. Now, I could have just done it as strings too and had to compare strings, but I have to put a bunch of quotes in. And I don't know about you, but have you ever typoed anything without noticing? Yes. Spelling's hard. So you can't typo scissors because it's the variable name, and it will auto-complete it for you. And if you don't type in the right word here, you get a red line. Versus if you're doing it in quotes here, hey, did they type in the word scissors? Now, this is nice enough to tell you you spelled it wrong, right? But, you know, it's a nicer thing here. So having these variables with names, generally we call them constants. I want this to be a constant value. There's ways to do that we don't really care about right now. We'll get into that next semester. Just makes my code look a little prettier. Didn't change the functionality at all, but it looks a little easier. Now it's a little easier for me to read, right? And that way I still get to use my numbers. All right, so if I didn't win, how about a tie, right? That's the next easy one to check. So else if my player throw is equal to the computer throw. That's a tie, right? And if I didn't win and I didn't tie, that must be a draw. Now, I like checking tie because it's less typing than it was to check, lose. You lose. There we go. That's tie and draw are the same thing. I'm getting confused. So if you didn't win, you didn't tie, then you lost. I'll post all this code on GitHub. It'll be out there. Because this is just one check versus 2 checks, right? So it was a little bit faster. So, and I could repeat all of this for if the player is paper. I could do it again. I could do it again if the player is scissors. I could do it again if the player is lizard. I could do it again if the player is Spock. It's a lot of typing, right? I would kind of rather not do that here. So instead of doing it that way, we can just leave that in here. I want to just do all of the checks for winning, and all of the checks for drawing, and all of the checks for losing. Right? Well, really, I could just check this one right now. Right? The first one is the easy one to check. Print tie. So no matter what, I don't care what the player is. If they're the same as the computer, we tied. Right? So that's the first one. Else if they didn't do that. Now, the win conditions, this is a little bit long here. So I'm going to have this is a way to win, or 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 this is a way to win. I'll have 5 different ways to win. Right? Because there's 5 different things the player could pick. So this is going to be long, but instead of having 5 different blocks here, I'm going to put it all in one because it's one way to do it. So we can say if the player throw is rock, right? We did this one already. Then the logic with this, though, now we have to be careful because it's the player's rock and the computer something, right? To figure out if I won as rock. So I'm going to and this one together. And then these are ors, right? So if the player's rock and the computer is scissors or the computer's lizard. So really I want the ors first, and that is going to happen with our order of operations, right? I think we looked at that last time. I think we get the ands first. So this is good. So we definitely want to make sure we're doing our parentheses for the ors, right? Otherwise the ands would happen first. I would get this and this or that thing. It's always worth checking, or just put them in here because it's not hard, right? So this is the case, and then all of this I'm going to throw in another set of parentheses because that's one condition here. So that's one way to win. Right? Now, we haven't really gone on to other lines before. So eventually, if you start typing and you hit an enter, it'll figure it out for you. Sometimes here. Let's see, is that where it's doing it? There's weird rules around for when you can be on extra lines. It doesn't like all the spaces. It hates spaces with my parentheses. I like spaces with parentheses. Python does not. Can we make that? Redundant parentheses, that's okay. So that one, then all of that's one way to win, or I need another way to win. So if the player throw is equal to paper, and the computer throw is equal to, so paper beats rock, or the computer throw is equal to paper Spock, right? Spock, the paper disproves Spock or something, I think. And all of that, or, now notice it's still red though, because it's unhappy here. At the end of this line, if you put a backslash, that's the key to tell Python, hey, I'm just going to keep on going down to another line, but pretend like I didn't do that. I haven't got to that before, I'm sorry. Sometimes it throws it in for you if it's feeling helpful, but we can add those ourselves here. So, or, and we have another case. So now we have, the indentation gets so weird on this too. If player throw is equal to scissors, right? Can I back that up? I want to back it up a little bit. Wow. Okay, there we go. Scissors and then the computer throw. So scissors will beat paper, or the computer throw is lizard, right? Scissors decapitate lizard. Right, and then another case here, right? So then this is the idea that you don't necessarily have to have nested ifs. You could have that all in one case here, right? An if with an if inside of it, you could maybe just do as a single if with your and ors or other logic here. Now, you might not say this is easier to read, and that's probably fair. This gets a little bit wordy here, but that's okay. We'll figure it out here. So then we have rock, paper, scissors, lizard. And then the computer throw is, so lizard beats, I have to go look at the picture now. Scissors, lizard Spock. What does the lizard beat? The lizard beats paper and the lizard beats Spock. No, yeah, paper and Spock, okay. This is a terrible picture. Picked a bad one here, so grainy. So if the computer is paper, or the computer is Spock, right? Or one last case here then. If my player throw, again, this indentation is driving me crazy. I like when they're all in the same tab. There we go. My player throw is Spock, and then my computer throw, oh, I'm supposed to take those spaces out. Try and be consistent. Computer throw, so then Spock beats, let's have to go back to the picture here. Rock and scissors, sure. Rock, or the computer throw is scissors. So all of that then, I could print, you win. And if you didn't win, and you didn't tie, you must have lost. Thankfully, you don't have to do this again. So, again, not having to do all of the loss conditions is kind of handy here. And we could try and indent these any way we want to make sense here. There's not really a right or wrong way to do those. Like, maybe you'd want to put the ands, like, down here. I don't know. I don't know if that's any easier or not, but we can, something to make it kind of easy to see. At least now I can see them on one page here. Right? Really, that's rock, paper, scissors, lizard, Spock. We try it again, or try and run it. I'll leave this first one commented out here. Code, and I want to comment. There we go. All right, let's give it a run. All right, so what should we try? Paper? We won. All right. Now, at this point, you don't see what the computer played, and that feels a little bad. You just figure out you won. It's nice if like it gives you the sentences, but that's a lot more code. We won with rock, and we're on a roll here. Oh, now we lost. Okay. So if we wanted, we could print, the computer picked this. So that's when someone who had the list might be really nice, right? If we put all these things in a list, then the random number could be an index of that list. Works out pretty well. So sure, we can add that in because that was cool. So then, and that's probably easier than an if, else if, else if, else if, and print, like with 5 different prints, right? Maybe. So this is, I don't know what, throws. Then we're going to have rock equals, there we go. Rock, paper, scissors, lizard, and Spock, right? And we get the computer's throw, we got their choice, and then we can print the computer picked, and we can do this as a formatted string. So we have the throws, index of the computer choice, but remember, because we picked 1 to 5, we don't have indexes 1 to 5. We have 0, 1, 2, 3, and 4. So we'll probably want to take away 1 from that. Okay. So that way we'll get 0 through 4, and we don't have to change the rest of our code. We could have changed it. It could have been 0 through 4. But then if you ask people to enter a 0 in a menu, they get kind of confused. Because most people don't know how to start counting at 0. Only the smart people do. But now, hopefully now it'll tell us at least what happened. So let's pick paper, and they pick Spock, and we won. Oh, fun. And we picked rock. They picked rock, and we tied. Looking good so far. They picked scissors, we won. Okay, so it seems like it's working for us here. Tested it out a couple times. It's hard to test these ones that are random, right, without just doing it a bunch of times. So we just ran it a bunch of times. Right? We'll learn some better ways eventually. It gets a little tricky, but there's ways to do it. That feel okay? So again, any of these approaches is fine. You could have 5 different blocks like this, and that's okay. There's nothing wrong with that. It's maybe a little bit more typing, but it reads really nice. This is a bit of an eyesore to do it this way. Sort of works. I don't know, like if you look at your parentheses and things, and maybe. It's not too bad. What do you think? That make sense? All right, so it's just practice, right? Making sure we get the ands right and the ors right and the other ors right, any one of those cases. Because if we get any one of these ones off, the whole thing's going to get really weird really quick, right? Because you can't win 2 different ways. Yeah?
Oh, right. Did you say you're posting this?
Yeah, I'll post it.
Awesome, thank you.
Yep. Yeah, it should be, because I deleted that .git folder, I can do it here. So here's lab 2. All right, awesome. Yeah, and I think I saw one person, they went as far as every single possibility. They because they have the words like lizard, poison, Spock. They would say, okay, if I was lizard and they were Spock, lizard, poison, Spock, you win. Which is much prettier, much nicer. But at that point, now we get, it's a lot more typing. Yeah. So maybe. Then, it's up to you. That's really, I guess, just a style preference. What do you want it to look like? And those sort of like small touches really are, most often we're familiar with video games and things like you can tell when someone put a lot of time into a video game and you get all those small details rather than just the core stuff, but it's just up to you. And that's what's fun about software. Right? You can make it do whatever you tell it to do. Whatever you think is going to be a nice way for it to interact, you can do it like that. All right, so we open back up our recent, there we go, for branching here. We'll come back to branching. All right, so we got to the, ooh, look at that. Speed search and tree views. That's handy. Some of those tips are nice. Okay. So doing ands and ors is probably the hardest bit here. Trying to make sure we know what is the right way to combine these things. It takes a little bit of puzzling through to make sure we got it right. Now, like for our case for the project, it's just they enter this, or they enter this, or they enter this. It's not a lot of complexity there. Next one will get a little bit more complex with some of this logic here.
I feel like the project was actually easier than the labs.
Really? Okay.
I don't know.
Also, I gave it like the second week. It was supposed to be the second week of class, but I think it ended up, what did I forget. So I tried to start it a little bit slower. And yeah, it's okay. Those are just, I'm not going to help you with them. Really, like I'll tell you the right direction to go with those, but where the labs I'll help you with. So, rock paper scissors lizard Spock is a lot of typing, but I don't know. There's no math involved. Maybe if you ask ChatGPT, it does some weird stuff with math, and it like takes it does the numbers and subtracts one from the other, and if you're even or odd, you mean you won or lost. And like I didn't even know you could do that with rock paper scissors lizard Spock. So I know who copied off of ChatGPT. Nobody thinks, oh yeah, I'll just take your number and subtract it from the other number, and of course if it's odd, you won, because I noticed the pattern. Yeah. Unless you're some sort of savant. Maybe our math majors might have noticed that, because you love numbers, even more than we do, but like, I don't know, just some of those approaches. It's not very helpful. We should compare, right? That'll be a fun exercise. Let's compare it here.
But why did it take a math route? That's weird.
Because it's efficient, and so because it trained off of a lot of stuff they find online, a lot of stuff online that you'll see are like, hey, I want to come up with the most efficient one, and there's this website, what is it now? Oh, I have no brain today, I need more coffee. Leet Code, they're just algorithm puzzles. And
yeah, I love Leet Code. It gives you like a language,
yeah,
and then like a bunch of puzzles.
Yeah.
Most of the puzzles puzzles are like from either like actual job interviews or algorithms like raise.
Yep.
Like they give you like a list of numbers. You gotta organize that a certain way. Move the odd numbers, or like they'll give you a list of words.
Yep.
You gotta see if they match the first character. It's really
Yeah, there's lots of puzzles. So if you like puzzles, it's a lot of fun. Our class 350, algorithms, analysis, and design, it's basically that. But looking at the really smart stuff and ways to optimize algorithms. So when you learn from stuff that's available online, you get stuff like that. That's like, hey, we want to hyper optimize it here. And doing stuff with numbers is much faster than strings, because to compare a string, you have to look at this number and this number and this number and this number and this number, right, to see if they match. So checking scissors, you have to do like 6 different comparisons to see if they equal. It's 6 times slower than saying, does 2 equal 2? Right? So, sure. No one's going to care if your rock, paper, scissors, lizard, Spock is 10 times faster. I guarantee no one cares. But sure. So let's see. I'll just copy paste all of that here, right, and see what it gives us here. And we'll specify in Python. See if it comes up with anything here. See how readable it is. Look at that. It's given us functions. We haven't got to functions yet. So again, if you gave this to me, it's kind of obvious. Choices, okay. Computers a random number. We return choices -1. Okay, we were doing basically this with the computer's choice, but they're turning it back into a string. Sure. Get the user's choice. Pick a number. And look, okay, so they did a print all in one line here. I just don't like the new line characters. I don't know. Maybe I'm lazy. And try and get some numbers. With exception handling, we haven't got to that yet either. This is to keep your program from crashing, sure. Eventually we get a number back. And this is a loop. We're going to talk about that next week. Loops are lots of fun here. Okay, determine the winner. The win conditions. Okay, oh, we have a dictionary with win conditions. Rock will win against lizard or Spock. Or scissors or lizard. Paper will win against rock or Spock. Scissors will win against paper or lizard. That's fun. So we've got a key, an associated value of a list of the things it beats. Check if it's a tie. Check to see if the computer choice is in the value associated with the key of the user's choice in the win conditions list. Remember, the value associated is the thing after the colon. So the value associated is a list, and we can use this membership operator and say, hey, is there value in a list? Okay, so if the computer is in this condition, then we must have won, because they're in the list of things we beat. And if not, then we lost. Okay, so welcome rock, paper, scissors, lizard, Spock. Get the computer user's choice, get the computer's choice, print you chose, computer chose. Result is determine the winner, and print the result. All right, this is not too terrible.
It's actually cool.
This is fun. Using a dictionary with lists embedded. That's fancy. Yeah. I mean, this would scale out even like as you get bigger and bigger and bigger, more and more options, right? You just add more things to your list. That's kind of fun. Nice. They did a nice job. Run play game function to start the game. And it's even telling us what it did. How handy. Okay, ChatGPT, not too bad. Not too bad. I wonder if we just Google here. Rock, paper, scissors, lizard, Spock in Python. Let's see what we get just off of Google here. First hit Stack Overflow. Okay. This looks a little bit more like ours here, right? So if it's 1 and 2. Now, they didn't do order of operation. They didn't force the order of operations, though. I feel like this is going to cause trouble, right? Because ands happened first, and then our ors happen. Right? Isn't that going to have trouble? Oh. This is the question, not the answer. So the question, of course, has bugs. That's what I get for trying to jump ahead, right? Trying to figure out why I'm always winning. Oh, we just figured it out, right? Because eventually, one of these will be true, right? The computer is 4 or 5 or 4 or 5 or 3 or, right? Okay. Then what's the answer here? There. Ands and ors first. False and true or true is true. False and true or false is false. right? Because the or. Okay, nice. A medium post. Oh, look at that. Okay, so they've got the verb in here. So they have a dictionary of dictionaries. Look at that. So we can say rock crushes scissors, or rock crushes lizard. Paper covers rock, or paper disproves Spock. There we go. That's fun, right? And where's the verb here? Get verb. We're getting the verb for a winner and a loser. The verb's key of the winner, key of the loser. So a dictionary within a dictionary. What's the value associated with this? You can put dictionaries inside of dictionaries. We don't get to that until, what chapter is that? We'll go back here. Chapter 8. But you can do that, right? So it gets to be a little bit harder to read, but readable, maybe, right? Here's the dictionary, key of winner. So, okay, here's what the winner was, and then key of the loser is going to be the value associated with that one within that dictionary. You can go down some weird rabbit holes if you spend too much time just Googling stuff, right? All right, that was fun. So some other examples then. So let's see, we did insurance, car insurance. Let's see if you're allowed to register for a class, right? And there's certain classes you have to have prereqs for, right? So maybe we have a list of, or let's say to call it a list. We'll call this completed classes. Is a list here, and we'll put CIS 1501. We'll pretend you completed CIS 1501. You're all on track for it, right? Which is doing good. That's awesome. What other classes? What's like Calc 1? Is that math? 115? 115 for Calc 1? Okay, cool. We got Calc 1. We got 1501. What other classes? What's like a composition class? English something or other?
Comp 110.
Comp 110?
Yeah, something like that.
Okay, cool. One other class, like a science class. What's some fun science? Chemistry?
There's
I'm something. Yeah, I don't have it yet. It's not like.
Chem 130, what's that, 134?
Sure.
134, yeah.
The numbers don't really matter. It's like that show. Okay, so we got a list of completed classes, and then now we need to know what classes are prereqs, right? So sort of the similar idea like we did with that rock, paper, scissors, lizard, Spock. We can make a dictionary with a bunch of values here, so it should be fun. So if we have, how about CIS 2001, then its prereqs. Do we want a list for that? I don't think we want to put a list within a list. So we'll say CIS 2001 prereq. Now, I want to be lowercase. That seems weird though. CIS 2001 prereq is CIS 1501, but there's more than one, right? So let's go look that up. Catalog. I think it takes math, right? Let's make sure we get it right though. Where's our list of classes? Courses A to Z, CIS 2001. Look at it even has the Boolean logic for us with parentheses. With parentheses, friends. This is amazing. It made me so happy just now. All right. All right, so I guess we have a list here. CS 1501. Now, I don't think our little program here can do ORs for this, so we're just going to say 115 because that's going to get a little trickier for us, and that's okay. We don't need to get too hard at the moment, right? So here's the list of prereqs, right? So when we ask what class do you want to register for, when we go find in our list here, I guess let's we'll make it the catalog, right? That'll be a dictionary. We can put a dictionary here. So then the key then will be CIS 2001, and the value associated with that key then can be the list of prereqs. What are we doing here? Catalog prereqs equals a dictionary. Now, what was 1501? We did have 115 with a star. What's the star mean? That's like a co-requisite, right? If they put a star there, isn't it? You have to be taking it at the same time. It's Calc 1. What's one? Calc 1 for biology and life science? They have a different calculus?
Oh.
Wow.
Yeah, come for everybody.
Yeah, I think the star is co-requisite, right? Is it say anything down here? Star. Courses may be taken concurrently. We're not going to build out a registration. These are actually somewhat complex. Not like crazy, but takes a little bit more logic than we want to do right now. Probably more trouble than it's worth. All right, so you've completed 1501 and one of the math ones here. Not as a co-record, you completed it. All right, so we got that one here. And let's see, what other, so then there's science. You'll take data science 2. Where's data science 1? Am I missing it? Wasn't there a data science 1? Is it really?
There should be.
What's the? Oh, it's not a CIS class. That's why. It's an ECE class because our program is multidisciplinary. You don't just learn from the CIS department. You learn from other departments. So the ECE folks actually do some really cool stuff. We just always make fun of their programming because their programming is awful. But like if you look at some of the research they do, it's super cool stuff. But this one here, I believe we can find data science 1. Yes, ECE 3100. Mathematical computational solution methodologies needed in the field of data science, including, comma. A weird comma there? Data processing, analysis and visualization, regression, pattern recognition and classification, time series prediction, and clustering. This is where you actually get to some interesting stuff in data science. You're going to do some of the actual fun things. You got to spend a little bit of time understanding how code works first before they drop you into it. But, so now this one has a prereq, right, of 1501 or 150, and math. I think this one is Calc 2, right? Oh, linear algebra. Ooh. Yeah, linear algebra or differential equations with linear algebra, if you really love all the math. I think this one's Calc 2, isn't it? 217?
No, 116.
160.
Oh, what is 217? It's not clickable. All right, so then you completed linear algebra. Wow, that's really early, isn't it? And your applied stats or engineering probability and statistics. We love teaching people this one for some reason. Our IMSE department does it. Sure. This is like calculus-based statistics, right? Bioengineering, probability and stats. They have their own course. That's cool. So this one has a lot of prereqs anyway. That's why we were trying to go with this one. So data science 1. Let's add this one into our prereq list, right? So ECE 3100 then, classes. You have to take 1501. We'll pretend like the other ORs don't matter here. And then you'll probably take linear algebra, right? I think for this program. So math 227. Math 227. And then you wanted IMSE 3, oh, I can't remember the numbers already. 317. 317. That's got a bunch here, right? We're moving our way up. So when do you take, wow. So then our data science 2, data science, come on, go back. There it is. Nope. Data science 2. So you needed 2001 and probably the stat 305, right? Introduction to data science. There we go. So CIS 3200 doesn't need data science 1, weirdly, right? It's not on the list here. Well, I guess you can take, okay, so you can take that one or stat 305 if you've done intro to data science. Nice. Another comma, adding more in the list here. This is CIS 3200. So this one needed our next class, 2001. Should we say the ECE 3100? That's fine. We'll say that one. Okay, so we got a couple here. And then 350 you'll take. So you need 115, 200, and 275. Now, 200 can also be 2001. I don't know why they don't list that here, but 2001 counts for 200 if you're taking 350. And then discrete structures as well. 275. There's like a bunch of these that are just a big sequence here, right? Discrete needs math and concurrent in 200 here. You guys gonna take this one in the winter then? Is that what the plan is? I should look at what the plan is. I don't remember anymore.
I think it's only in the winter,
Okay.
because I wanted to take it. But I didn't see it was available in the fall, so I think it was just in the winter.
Well, we definitely offer it in the fall, but you probably didn't have the prereq yet because you needed the 200 or 2001 course.
Probably, yeah, that was probably it. But I took the math class, so it was probably
Nice.
CIS, yeah.
So then 275, we'll do that one as well. 275. 275 then has prereqs of CIS 2001 and Math 115. Math 115. Math 115. All right. We're getting there. We don't have the full list of completed courses yet. Let's see, do we so we'll qualify for this one, but not this one yet. Not this one yet, and not this one yet. We're getting close, right? So if we wanted to see which classes we can take, right, I guess. So if we wanted to loop through then, so for every class that's in the dictionary here, right, that has the prereqs, we'll see if our completed classes fulfill the prereqs here, right? So
CIS 2000.
yeah, so we can see, so if then the values associated, right, would be our list here. So if our catalog prereqs, key of CIS 2001, right, so the key of this will give me the values associated. So I get a list back out here. So if this list then, right, now what? I need to see, do I have the classes in my completed list? Right, we looked at a couple different list operations here. We did our types. Is it in the list? I don't think it was in this one. No, that's the basic ones. Where is it here? Common data type summary, was it? I think it was the common data type summary had it. No? Goodness. This was the one that had the union and intersect. Remember? Can we just search it? Union, intersection. Really? Didn't we look at like a set intersection?
I think we did.
Is it just in sets? It's in here. I know we talked about it.
Yeah, we did talk about it.
Move, pop. Okay, so for sets. Okay. Union, difference, intersection. So if the intersection then matches, right? If I'm trying to think of the easiest way to check if those are in here because we haven't done loops yet. Can we check in? I think we can check in. Is that in the completed classes? Let's see if we can check in first. And you meet the prereqs for CIS 2001. Let's see if we can do that. I didn't want that one. I wanted to run selection. There we go. No, it's not working here. Not do Python list subset. Another list. It's our Google. Oh, that's that's sets. I'll do it with lists though. Is subset. That's for dictionaries. Set all. Oh, that's messy. All's probably fine. Gonna correct duplicate items. Is subset. I guess we could do that. That one feels messy. How How about if it equals, oh, it's going to be a set. Shoot, we have to make a set to do our intersection. Set intersection. I guess we can do subset. So we want to make a set out of that one? Sure. So here's, so we want a set of that is subset of a set of my completed classes. That gets kind of gross looking, but so we'll make a set out of this so we can do the subset operation. We can't check that with just regular lists. Doesn't let us do that. And we'll make a set out of the completed classes. See if this one works for us here, because we should have 1501 and 115. Do we not?
It says
I'm sorry?
no, I was just reading.
Oh, okay. Let me put it up at the top. I don't know if it's actually running here. I'm sad now. Try it up at the top. No, we did not meet the prereqs. Is a subset. It should have been, right? For CIS 1501, Math 115. Is a subset. A is a subset of B. Should be true. That one's not. We shouldn't have to make them with. That's so sad now. All right, so if I make them dictionaries, then we'll just make them sets here. Maybe this will work a little bit nicer. Make this one, so I don't have to do any of that conversion. Is a subset of our completed classes. That one ought to work, right? It doesn't. Prereqs for 2001 should be that one. Did I typo? CIS 1501. That one matches math.
Oh, there's
Oh.
no H in there.
There we go. I did have a typo. Hey, okay. Now I'm at the prereqs. Goodness. So that was the problem with the first code too, probably. This is, I'm sure it's fine as a set because you can't complete a class more than once. The GPA thing aside, right? You only get credit for completing it once, so making a set's probably fine here. All right. Now we're able to do that. Now we can ask them, right? We can say, hey, what classes have you taken? Ask them a bunch of times. And we don't know how to make it stop very well, so we'd have to ask them like 10 times. That can get a little messy. Next week, we'll figure out a couple more cool things. And then say, hey, what class do you want to take? And then we can see, do you meet the prereqs of it? Right, so we can get the class to take. As an input of class want to take. Right, and then we can use this then instead right here. And so, okay, the key of the class you want to take. And throw that in as a formatted string. You can print it out, or else print you don't meet the prereqs. And probably we should tell them what the prereqs are here, right? So we should do that as a formatted string. So we'll get the catalog of classes to take. Right? So now we can ask them, okay, what class? So they say it's 275. We don't meet the prereqs yet. Right? We've got the math, but we don't have the CIS course yet. Bummer. We're getting closer. All right. So this is fun with other conditions, right? It's not always just going to be the regular ands and ors, or like, is this number greater than this number, right? Lots of different things we're going to put into these if cases, these expressions, and say, is this true or not, right? When we're dealing with interesting types of data. All right, awesome. I think that's pretty good for now. You got the rest of the practice here. You can do, not Discord, in Zybooks, right? Because lots of people still need practice with Chapter 4. No one was even working on it while I was talking. That's impressive. Usually people try and multitask. Sure. So practice on that. We got the project coming up due on Monday. Remember, Monday in class, the first thing I'm going to do is go for a solution to it. Right? 30th, 12:30 p.m. It'll go pretty quick. Like you said, this was not too hard. Right? If you got the labs done, this one should be easy enough to do. Just some arithmetic here. And then we'll talk about loops, and we'll talk about our next project, which we'll have 2 weeks on. Oh, I got to fix that, the syllabus there. I'll fix that in a little bit and upload a new version. Or I can download it. Can I download it? I can hit download. We can make that work because we got to fix our dates here. So we're a little bit off on the project. That's okay. So this was this week. This was this week. Nope. Project 1, and then this one will be this week. Right, so it'll just be due on the day we do midterm review. It should be fine, as long as it's done before the midterm. Right, 16, 30, 14. And we come back from midterm, we'll pick up the third project. We'll start the final project on the 18th, just before Thanksgiving break. So if you want to get started on over break, great. If you don't, that's okay. Actually take some time off, that's good too. Let's go to another page. That's a bad page break. And then again, the last week of class is just final project work time. So if anything has to slide, we might bump it into that week, but usually we should be able to get through the content, and we've got the last 2 meetings just to work with you on whatever's happening, making sure you get that done. Ideally, it's done before finals week, so you can actually focus on your other finals. That's my goal. I know that doesn't always happen, but and then for our final exam slot, we will present your final projects. So I'll actually shut up for once, and you all have a turn to talk. Go up in front of class, run your program, ask a couple questions about the code. Again, it's really obvious if you copy-pasted the code because you have no idea what your code's doing, right? And then you're doing it in front of everybody. So just a little bit of that extra fear there to not do that. It might be healthy for you, right? It won't be too crazy, I promise. It's nothing super difficult, and we've got lots of time to work on it. So we should be great, okay? That's the plan for the rest of the semester. Awesome. Well, I'll see you folks on Monday then.